Hello viewers, today we'll be looking at the area of triangles and this will be part 1. We'll be looking at area of triangles and this will be the part 1 episode of the areas. At the end of this video, some of the expectations among others include: number 1, we should be able to find the area of a triangle given the base and the height of the triangle. We should be able to find the area of a triangle given the base and height of the triangle. Also, we should be able to find the area of a triangle given the length of all the sides. So we'll commence by looking at a scenario where the base and the height of a triangle is given, and then we're expected to find the area. So let's look at this particular triangle. In this particular triangle, we see that we have a base, which is represented by B is equals to 10 centimeters. And then we have a height, which is 5 centimeters. Let's take note that whenever we are finding the area of a triangle, the height we are actually looking for is always the perpendicular height. Perpendicular height, meaning a height that is at 90 degrees to the base. So this sign shows 90 degrees, and this height is perpendicular to the base. So like we earlier said, our height is 5 centimeters and our base is 10 centimeters. And for emphasis, we stated that the height used for this particular area is always the perpendicular height. Now the base is 10 centimeters, while the height is 5 centimeters. The area of a triangle is simply the base times the height divided by 2. That is, the base times the perpendicular height divided by 2, which can also be simply expressed as half base times height. We know our base, which is 10 centimeters, and then we also know the height, and that height is the perpendicular height, and that is 5 centimeters. So once we substitute it into this particular equation, it is half 10 centimeters times 5 centimeters. So you have your 10 centimeters times 5 centimeters, which is 50 centimeters squared. And when you divide it by 2, you have 25 centimeters squared. Therefore, our area is 25 centimeters squared. So here we'll be looking at a scenario where the length of all the sides of the triangle are given. All the sides are given, and we'll be looking at a formula which is called the Herons formula. Heron was a Greek mathematician, and he came up with a formula where we can find the area of this triangle given the length of all the sides. So you have from here to here with the length equal to A, and then you have from here to here, which is another side, with the length equals to B, and then the third side from here to here with the length equivalent to C. Now, Heron came with a formula which gives us the area and is equals to the square root of everything inside it, which is S bracket open, S minus A bracket close, times S minus B bracket close, and then bracket open, S minus C. And then this gives us the area, that is the square root of all the activities that happen inside here. Now, what is S? S is given by adding all the three sides, that is A plus B plus C, and then multiplying it by half. In other words, multiplying half of the sum of all the sides. And you know that the sum of all the sides is the same thing as the perimeter. So our S is simply expressed as half of the perimeter of the triangle. So here we'll be applying the Herons formula in order to find the area of a particular triangle with the three sides given. So let's just quickly remind ourselves of the Herons formula in finding the area, and it's given by this formula. So the first thing we'll do is to calculate S, and S is simply calculated by taking half and then multiplying it by the sum of all the sides. This is an equilateral triangle, that is, all the sides are equal. But just to take note, the Herons formula works for all types of triangles, whether they are equilateral, that is, all the sides are equal, or whether they are isosceles triangles, where only two sides are equal, or even for a scalene triangle where the three sides are different. So let's just continue. So if we're to find S, which is half times the sum of all the sides, if we take the sum of all these sides, we have 2 plus 2 plus 2, and that gives us 6 centimeters. And if we divide that by 2, or if we multiply it by half, we have a scenario where S is equals to 3 centimeters. So S is 3 centimeters. Now that we have been able to calculate the value of S, which is equals to 3 centimeters, and we know what all the sides of this triangle are, we know that our A is 2 centimeters, our B is 2 centimeters, and our C is 2 centimeters. Like I said earlier, this Herons formula works for all triangles provided the sides are given. Now let's just remind ourselves what is the area. Our area is given by this formula. We know the value of S, which is 3. We know the value of A, which is 2. We know the value of B, which is 2. And we also know the value of C, which is also 2. So all we'll simply do is to substitute the values of S, A, B, and C respectively into this formula, and this is what we have. So you see that we have 3 minus 2, 3 minus 2, 3 minus 2. So if we simplify this, we have square root of 3 into 111, and that is the square root of 3, because 3 times 1 is 3, 3 times 1 is 3, 3 times 1 is 3. So what we have is the area of this triangle is equals to the square root of 3 centimeters squared. Now that we have been able to successfully calculate the area of the triangle using Heron's formula, we will find the area of the same triangle using the half base times height formula, and then we'll see whether we'll get the same thing. We know the dimensions 2 by 2 by 2. That is, the length here is 2 centimeters, the base here is 2 centimeters, and the other length here is 2 centimeters. So in this particular equation, we know our base, but what we'll simply need to do is to calculate the height. So we'll divide this triangle into 2 from the peak all the way down to the base, and that divides the base into 2, so we have 1 centimeters here, and then we also have 1 centimeters here. But the whole objective is to be able to calculate the perpendicular height. So we have 2 here, and we have 1 here, and we also have the height here. So using Pythagoras' theorem will be this side squared, that is comparing these 3 sides, h1 and 2. So it is the longest side squared, which is 2 squared, is equals to 1 squared plus h squared. And that's what we have here. 2 squared is equals to 1 squared plus h squared. And if we simplify that, we have 4 is equals to 1 plus h squared. By the time we take the 1 to this side, we have 4 minus 1, which is equals to h squared. And that ends up with us having 3 is equals to h squared. And if we take the square root of both sides, we have square root of 3 is h. So our h is the square root of 3 centimeters. So we succeeded in calculating our h, which is the height, and then we know our base, which is b, as equals to 2. Therefore, we can use this formula, area, which is half base times height, in order to calculate the area of this particular triangle. So half times the base times the height, these 2 will cancel these 2, and then we have root 3 centimeters squared. Remember, this is the same value we got when we used the Herons formula. Therefore, we can conclude that both the Herons formula and also the half base times height formula are both correct, since we were able to successfully get the same answers. Thank you. If this video added any value to you, kindly subscribe to this YouTube channel, kindly like, and also kindly share. Thank you.